Chapter 68. Chapter 68, solving equations by completing the square. Okay. If we were to expand 1 times x plus or minus a squared, this has to be a 1 times x squared. We get 1 times x squared plus or minus 2ax, a double product, plus a squared. Note that whatever number you need here to complete the square, it is 1/2 of the coefficient of x. Also note that the number you need here, the a squared, is that number a quantity squared. Okay? The arrow should be over here. I have drawn it on my software. It comes out properly, but when I typeset it, I can't get it to do the proper thing. Example 1. Find a and b to complete the square to get x plus a quantity squared, which is x squared plus 12x plus b. Find a and b. This is 1 times x squared. This is 1 times x. This is twice a. So 1/2 of a is 6. That goes here. And the 6 quantity square is 36, and the arrow should go right here. So a is 6 and b is 36. That's completing the square. Example 2. Find a and b. 1/2 of 20 is 10. That's 10. And then 10 squared is 100. So a is 10 and b is 100. Minus, minus. Example 3. You wanted to complete the square. Find the a and the b. 1/2 of the coefficient of x is 5/2. 5/2 quantity square is your b. Find a, b, and c to complete the square. You don't have an equation, okay? You cannot add something to both sides. But you can add 0 in the form of a number minus the same number. You need a 1 here. So factor out the 3. How can you factor out the 3? There's no 3 in here. Make it a fraction. Check yourselves. Distribute, you get 3x squared. Distribute, you get 3 times 5/3. And 3/3 drops out. You're left with 5/x. 5/3 times x. You need this number squared to get the constant. So inside the parentheses, inside the brackets here, I am adding 0 in the form of a number minus the same number. Now this is needed to complete the square, so these 3 terms become x plus 5/6 squared. And then I have, be careful, 3 times negative 25/36, which is 25/12. So a was 3, b was 5/6, and c, this is plus c, so negative 25/12. Solve the equation by completing the square. Can I factor this? Maybe, maybe not. But I want to find out how to do it if I cannot factor. Okay? I'm on my way to developing the quadratic formula. The first thing I want to do is I want to get the 60 out of the way. I don't need it, it's confusing me. I have an equation, subtract 60 from both sides. You want to complete the square, you have 1 times x squared. You need 1/2 the coefficient of x, which is 8. And the constant is 8 squared. So now I am adding 64 to both sides. That leaves me with a 4 here and a square here. Square root on the left, x plus 8. Square root on the right, plus or minus 2. Plus or minus because I have an unknown. So subtract 8, and x is negative 8 plus or minus 2. Negative 8 plus 2, negative 6. Negative 8 minus 2, minus 10. Okay, example 6. Solve x squared plus 16x plus 50, which is 0. Get the 50 out of the way temporarily. This is 1 times x squared. Always need to check that, otherwise I cannot do the half of and square. 1/2 of 16 is 8. And 8 squared is 64. I add 64 to both sides. I get a 14 here. I get the square root of 14. There's nothing wrong with getting square roots. Plus or minus, and then I subtract 8 from both sides. This is my answer. Negative 8 plus square root of 14. Negative 8 minus square root of 14. Again, completing the square. 3x squared plus 5x minus 7. Get the 7 out of the way. Divide by 3 to make it 1 times x squared. And so on. So I have 1 times x squared. I need 1/2 of this number. I need, 1/2 of this number, which becomes 1/2 of 5 over 3. 5 times 1 over 3 times 2, 5 over 6. And I also need 5 over 6 squared, which I add to both sides of the equation. Earlier I did not have an equation, so I had to add 0, this number minus that number. Here I can add it to both sides. So I get a square. I get a common denominator here to add the two fractions, 109 over 36. Take the square root of both sides. X plus 5 over 6, plus or minus the square root 109 over 36. 36 comes out as 6, 109 stays 109. So same denominator, negative 5 plus or minus square root of 109 over 6. If you understand these steps, you should have no difficulty developing the famous quadratic formula. Okay.